This is MAP4C, day 17. The lesson is 2.6, optimizing volume and surface area. The goal in the 3-minute review is to solve problems involving the surface area and volume of 3D shapes. Number 1, in the given diagram, the volume is 240 centimeters cubed. Find the height. So we see that most of the dimensions are given. Use the formula for the volume of a rectangular prism, a box. And essentially we're going to sub in for all the stuff we know, and what's going to be left is the thing that we don't know. It's 48. Equation solving skills here. We want to get h alone. We divide by 48 on both sides. And that is 5. Number 2, give 3 different rectangular prisms boxes that have a volume of 240 centimeters cubed. So that was one of them, 8 by 6 by 5. I'm going to use that one, 8 by 6 by 5, and figure out what the surface area, what the lowest surface area is. So let's do that. There's one box that's 8 by 6 by 5. And the surface area is, the top and bottom are both rectangles that are 8 by 6. The left and right sides are rectangles that are 6 by 5. And then the front and back are rectangles that are 8 by 5. So we put that into a calculator, and we get 236 centimeters squared. If we wanted to find some other ones, we just got to find 3 numbers, bing, 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 that multiply to get 240, right? And that's not, shouldn't be too bad. Lots and lots of possibilities. Try and make it easy on ourselves here. I suppose we could try and find a number so that when we multiply by 10 at the end, that'll give us this extra 0. So something times something has got to be 24. How about 6 times 4? And 6 times 4 times 10 is 240. Find the surface area there. Again, we've got pairs of rectangles that are the same size. That all goes into the calculator, and you should get 248. Notice that as far as surface area is concerned, this one has a lower surface area. So even though it's got the same volume, if this was a package of some sort, this would use less material. And that's kind of the theme for today's class. We have to do 3, so let's find one more. Let's see if we can come up with maybe a little bit of a goofy shape here. One that looks maybe almost like a milk carton type size. So if this is 3, this is 4, this is 20. And how do I come up with these numbers? I'm just trying to find, clunking away on my calculator, trying to find 3 numbers that when I multiply them up, I get 240. The volume's 240. And the surface area, again, pairs of rectangles. Pairs of rectangles, pairs of rectangles, pairs of rectangles. That goes into the calculator. And is it going to be more or less than these ones? Well, this seems to be a less efficient shape, doesn't it? And it means it's going to use more packaging. 304 centimeters squared. And so, which one has the lowest surface area? This one. And what's special about that is, well, it's kind of almost as equal length as width as height. These measurements are close to the same. It's closest to the cube, right? It's not a cube, but I'm going to call it cube-ish. And in fact, that's what we're after today is the best shape. Finally, the 3-minute review. Last question is to do a little algebra here. 8x cubed divided by 1,000. Well, I got to get rid of the 8 first. Divide by 8 on both sides. Now, the only tough thing here is because we know we have to get rid of cubing something, which is cube root. But if you don't know this in your head, how do you put that into your calculator? And again, it depends on what type of calculator you have. If you have a calculator like this one, you may have a cube root button. This one actually has a cube root button. So you'd hit 125, shift, or sorry, excuse me, you go shift, hit that button, then 125. Now, if you don't have that, I'm going to pretend that we don't have a cube root. You have to look for, this is the anything root button. So the anything root button, well, we need to tell the calculator that it's the cube root. So we put in the 3 first, hit that button, which would be shift exponent, which would give us that key right there, 125, and then press equals. Now this is how it works with a nice new calculator like that. If you have an older, and actually this is a screenshot from a graphing calculator. If you have an older calculator that behaves like the one on an iPod or the one on the computer here, what you have to do is you have to put in the inside thing first. You go 125, and then you tell it which root. Now notice that this actually has a cube root button on it as well, and maybe the iPod ones do. But I'm going to practice using the anything root key. Okay, so 125 is the inside thing, what we want to take the root of. And then I'm going to press this button. I don't have to press shift this time. That button. And notice it's telling me I'm going to take the anything root. And I hit 3 and equals, and there's my 5. Okay? If you're having trouble getting that into your calculator, that's something that we should be able to handle in class. So don't be afraid to ask about that. This anything root is going to come up this chapter and later as well. All right, that's the 3-minute review. A little more than a 3-minute review. But on we go to the lesson. Actually, a lot of the lessons already in the 3-minute review, as it often is. The expectations: find the optimal dimensions for a 3D shape given some constraint. This is going to be no surprise to you what shapes are the best. We saw in 2 dimensions, flat shapes, that for a rectangle, the square was the best. In fact, we even found out that a circle was better than a square. So it won't surprise you, I don't think. For a box, the best shape is a cube. You kind of saw that in the 3-minute review. For a cylinder, and this is pretty cool, for a cylinder, the best shape has, well, essentially, the best cylinder is the one that's the most boxy, or the most like a cube. And so what's special about this one? Well, you notice the radius here. The radius is half the height, or the diameter and the height are the same, right? So I'm going to say the height is the same as the diameter, or the height is 2 radiuses. Right? This is the cylinder that fits perfectly inside a cube. And so what types of questions are we solving here? Well, here we go. Ferd must put 1.5 liters in a milk container. He's choosing a box shape, so he's not going to use a cylinder, he's going to use a box. What's the minimum surface area? Well, if there's no other constraints and it's a box shape, we know it has to be a cube, right? And so we're going to say Ferd's going to make a shape that's a cube. Well, what do we know about a cube? The length, width, and height are all the same measures. We don't know what it is yet, but we know that the volume has to be 1.5 liters. Now remember, for a volume of 1.5 liters, there's some facts to remember. Right? 1 liter is 1,000 centimeters cubed, so the volume is actually 1,500 centimeters cubed. And we're going to use this fact to find out what x is, right? So the volume of of a rectangular prism, a cube, is just length times width times height. It happens to be x times x times x, which is x cubed. And we know that x cubed has to be equal to 1500. Length times width times height. Length times width times height is all there. And basically, it's this fact we're using where length, width, and height are all the same. And now what are we doing? Well, we've got to take the cube root of both sides. Again, put that into your calculator. Hopefully you've got that figured out. And you get about 11.45 centimeters. So this side length is 11.45 centimeters, which if you think about that, that's not very big to hold 1.5 liters of milk, but it works. That's why the cube's so efficient. But it asks, what's the minimum surface area? So I got to find the surface area, how much cardboard I'm going to use here. Well, for a cube, there's a shortcut. It's not pairs of rectangles that are the same. I've got 6 squares that are all the same size. So the surface area is 6x times x, 6 squares, 6x squared. And I can put that into my calculator. X is 11.45 from earlier, and you get about 786. So the minimum surface area is okay. I'm going to pick it up in part 2 and see you in a moment.